Hi, this is AP Classroom, Unit 3, Free Response Questions, Set B, Question 2. And there is, where's my highlighter? I don't know where my highlighter went. Oh well, oh here it is. No calculator is allowed for this question, which is good practice for us for the AP exam in 2020. All right, the problem starts right here with this table. So we have the table above gives values of the differential function f and its derivative for selected values of x. For part A, g is the function defined by g of x equals f of x squared over e to the x, and we want to find g prime of -1. So for A, where g is f of x squared over e to the x, we want to find g prime of -1. So first thing that we'll need to do is to find g prime of x. We have a quotient rule going on here, so plugging on through bottom, e to the x, times the derivative of a top. Now there's a chain rule sitting here. So the derivative of that is going to be f prime of x squared times the derivative of the inside, which is a 2x. Bottom, derivative of the top, minus top, f of x squared times the derivative of the bottom, e to the x, all over e to the x squared. Okay, now let's simplify this mess if we can. G prime of x is 2x e to the x f prime of x squared minus e to the x times f of x squared all over e to the 2x. Okay, now I opted to go ahead and simplify, and I divided out an e to the x out of all three of these. So I opted to take an e to the x out of all three. That's going to leave you with just an e to the x down here. You don't have to do that. It's just something that I see. I always try and simplify as much as possible before evaluating. Again, if you did not see that, it's not necessary that you do that. There's just g prime of x. Now I want to find g prime of -1. So that's going to be 2 times -1 f prime of a -1 squared, which is 1, minus f of -1 squared, f of 1, all over e to the -1. So we'll have -2 times now f prime of 1. Let's go up here and look. F prime of 1 is 4/3 minus f of 1. F of 1 is 2/3 all over e to the -1. And let's see, this will give us -8/3 minus 2/3 divided by e to the -1, which is times e. And this gives us -10/3 e. There is your g prime of -1. Okay, now today on this particular problem, I'm going to go ahead and take care of the scoring right off the bat, so that we don't have to kind of deal with it all the way at the end. I'm going to handle each part separately. So for part A, you get 2 points for the quotient rule, chain rule combination. So that's actually to get you to right here. So what they do is any error is -1 with a maximum of -2. Okay? Then you get plus 1 for subbing in the negative 1. And then you get plus 1 for that answer. Now, you do have to get to this far as answer goes. You showed that you substituted in the negative 1, but they do want to see that you can evaluate that table for f prime of 1 to get to here. You do not need to simplify down all the way to negative 10/3 e. So a simplified answer is not required. But you do need to show this line, so it would be okay to stop there to give you that final answer point. You have to show that point to show that you can read the table that's there. All right? Part B says, let h be the function defined by h of x equals that mess. Find h prime of 1. So here's part B. H is f of negative 2x. And we want to find h prime. So it's tricky because the nested functions, you got f inside of another f. So here we go. H prime, we're going to start on the outsidemost function. The outsidemost function is this f, so we do the derivative of that f, which would be f prime of, leave its inside alone, and then times the derivative of the next layer in, so we've done the derivative of that f, so that one's gone. Now let's do the derivative of this piece, which would be f prime of leave its inside alone. So we've done the derivative of that f, we've done the derivative of that f. Now we have to do the derivative of that negative 2x, so times the negative 2. And now there's no simplifying really to be done here. We just have to substitute in. H prime of 1 is going to be f prime of f of negative 2 times 1, or negative 2, times f prime of negative 2 times 1, negative 2, times negative 2. Okay. F prime of, all right, now let's read the table here. F of negative 2. F of negative 2 is negative 3. Times, and reading the table here, f prime at negative 2. F prime at negative 2 is 1/3. And then f prime at negative 3. F prime at negative 3 is negative 1. Times, and that gives us a negative 2/3. So we will have that h prime of 1 is a positive 2/3. That's it right there. So point values on this one is plus 2 for application of the chain rule twice. Again, similar to the last problem, it's worth 2 points, minus 1 for each error, maximum of minus 2. And then plus 1 for subbing in the x equals 1. So you're going to have to get to, well, subbing in the negative 1 gets you to here. I'm not sure if they're going to take it here, to be perfectly honest, or if they kind of want to get you all the way down to here so that they're double checking on the application of the reading the table. I'm not sure. I'm sorry. That's the best I can tell you. All right, part C. Part C says, let K be the function defined by that mess. Find K prime of negative 1. So this problem is a lot of derivatives and chain rule and etc. So K of x is equal to f of x times arc sine of x over 2. And we have to find K prime of negative 1. All right, first thing, this arc sine, that means not equals here, times inverse sine of x over 2. All right, so let's go ahead and do the derivative here. K prime, we have a product rule first, second, and then a chain rule within this one. Oh boy. So first function, f of x times the derivative of that inverse sine, and the derivative of an inverse sine is 1 over square root of 1 minus the u, or the inside squared, so x over 2 squared, times the derivative of the inside, and the derivative of that x over 2 is 1/2. This was first, derivative of the second, plus second, inverse sine of x over 2, times derivative of the first, f prime of x. I'm going to clean this up a bit. And we'll have f of x times, this is 1 over, this 2 I'm going to put in front, 2, square root 1 minus x squared over 4, plus, that just stays, inverse sine of x over 2 times f prime of x. Okay. At this point, rather than simplifying any further, I know I have to evaluate it at negative 1. I might as well plug in that negative 1. So K prime of negative 1 is f of negative 1 times 1 over 2 square root. Okay, this is 1 minus a negative 1 squared, so 1 over 4, okay, plus inverse sine of negative 1 over 2 times f prime of negative 1. Okay, let's see, f of negative 1, I got to go back to the table. F of negative 1 is negative 2. Negative 2 times 1 over 2 square root 1 minus a fourth is 3/4 plus, inverse sine of negative 1/2 right there, and that's negative pi over 6 times f prime of negative 1, table, f prime of negative 1 is 6/5. And then, oh goodness, what can we do here? This 2, that 2, we're going to divide out. So we have negative 1 over, and then the square root of 3/4. Square root 3 over 2. And then over here, the 6's divide out. And we'll have minus pi over 5. And then simplifying that, that becomes negative 2 over square root 3 minus pi over 5. Now, you do not have to rationalize denominators, so honestly, I'd probably stop right here. Actually, I probably stopped earlier, but I wanted to take you through the simplifying further. Okay, so here's where your points come from. You get +1 for recognizing and applying product rule appropriately. You get +1 for the chain rule. So doing this inverse, the derivative of the inverse sine of x over 2 and multiplying by the half. And then you get +1 for that answer. Now, again, a simplified answer is not required. And the trig function values are not required. So you don't have to do this inverse sine to -1. You don't have to do that. And you don't have to simplify all of this mess right in here, right? You could probably stop. Now, I would replace this f prime of -1 with that 6/5 and then stop. That would be perfectly fine. They don't want to catch you on arithmetic and that type of thing errors. So you do not have to simplify answers. I would caution you, though, as you're working through these, if you're not going to simplify your answers, then make sure that you don't make any mistakes in copying line from line to line as you gradually substitute information. You do need to substitute in that and that. Okay, once you get down to straight up numbers, then you can stop, but you do need to substitute in for all function values. Okay? All right, thanks. Hope you did well.